As much as life has changed over the last year, you're still pretty busy, so consider convenient COVID-19 testing from Quest. Get the same tests hospitals use without a doctor visit. Simply order online, select from drive-through or at-home options, and get results sent securely to your phone or computer. It's a great fit for your busy life. With over 25 million COVID-19 tests processed, you can count on Quest. So order your test today at questcovid19.com. That's questcovid19.com. With Masterclass, you can learn from the world's best minds anytime, anywhere, at your own pace. Learn how to ace your opponent from Serena. Improve your writing skills with Neil Gaiman. Learn how to negotiate with Chris Voss. All right. Those were the courses I chose, but you'll have over 90 classes to make your own choice, and they're all taught by world-class instructors. Now, of course, the master instructor, Dr. Neil Degrasse Tyson, has a masterclass of his own on scientific thinking and communication, and we all know how important that is in these times. I'm not the only one who's benefiting from my masterclass. My brother is an avid tennis player, and I sent him the gift of a subscription so he could get schooled by Serena. Did I tell him that it was a part of my subscription? Well, let's just say the answer rhymes with ho, ho, ho. From learning how to write anything from a book to a screenplay, to communicating with your boss, to how to make dinner worthy of a Michelin star or just the best scrambled eggs this side of a jumpy chicken, there's a master class for you. I'm in the middle of a course on sex and communication because I'm good at one of those things. Masterclass is accessible on your phone, web, or smart TV. You can get an annual membership to Masterclass and give one to someone else for free. Get unlimited access to every Masterclass for you and a friend right now. Just go to masterclass.com/StarTalkRadio. That's masterclass.com/StarTalkRadio.
Welcome to Star Talk, your place in the universe where science and pop culture collide. Star Talk begins right now. This is Star Talk. I'm your host, Neil Degrasse Tyson, your personal astrophysicist, and today's topic is proving Einstein right. Chuck, I needed you for this one because you're the man. You're the man.
I don't know how you need me because I never knew Einstein was wrong. So I'm trying to figure out where's the controversy?
Where's the controversy? Well, to talk about that controversy, I'm bringing in a friend and longtime colleague, Jim Gates. Jim, welcome to Star Talk.
Well, Neil, it's good to be back in the presence of a star.
No, don't.
James, please. It's okay. Thank you. I appreciate you.
I'm going to leave that one at that. So, Jim, you've been at this for a long time. Well, you've been an Einstein fan for sure, but a theoretical physicist, and you're director for the Center for Theoretical Physics at Brown University, Providence, Rhode Island. And that's a title. How long have you been doing that?
So when I was 66, Neil, I was recruited from the University of Maryland to Brown. I went around telling my friends, asking friends, why do you think they want an old car?
No, it's not the age, it's the mileage, okay? Actually, it's clear. We know this.
Well, one of my friends said, Jim, you're not an old car, you're an antique car. And
there you go. A preservable antique.
They hold their value.
No, I'm going to go one better than your friend, James. You are vintage, my friend. You are vintage. Vintage gets you even more money than antique, as they say.
Well, I switched after 33 years at my previous university. Came here and
where was the previous university?
University of Maryland, College Park.
Wow. And are you still on speaking terms? Because I would be kind of angry after 33 years that you just up and leave me. Just leave our marriage after 33 years.
Well, I don't know if marriage is the right analogy. But independent of debating that particular we did part on good terms.
Excellent.
In fact, I'm an emeritus professor there. Oh. And as an emeritus professor, I have taught 2 consecutive years courses on public policy.
Nice.
Evening courses. Yep. So I'm on good terms.
Wait, so if I remember correctly, you were on Obama's Advisory Council for Science and Technology, right?
That's exactly right, Neil. Served 7 years on the President's Council of Advisors on Science and Technology, PCAS, the acronym.
PCAS, that's right, that's right. So, but you weren't in the current administration. They didn't invite you back in there, huh?
I thought we were going to try to keep everything.
Okay, I just wondering. All right.
On the up and up here.
We'll leave it at that. So also,
that's all right. I was invited to be on this current administration's advisory council on writing jokes about technology.
Okay. There you go. So if you're director of the center, that's not necessarily an academic title. That's a job title. So you're also professor of physics.
Indeed. I'm an endowed professor here at Brown University. The endowment is the Ford. I'm the so-called Ford Professor of Physics. I'm also an affiliate mathematics professor. And on top of that, I'm a faculty fellow at the Watson Institute for Public Affairs and International Affairs.
Wow. Excellent. Okay.
Nice stuff.
So you're like, we should bring you back for 7 other excuses, 7 other reasons. Forget the theoretical physics. Yeah. We got some policy we got to figure out here.
Yeah.
So what we're going to do is we're going to structure this program. We're going to spend the first segment just, talking about why was Einstein proved right, or why did he need to be proved right? And then we'll go to Q&A. We go to our cosmic queries. And Chuck, you got cosmic queries for section 2 and 3?
I have the questions right here, and I have to say, these are some. Man, people are excited that you're here, Professor. They are excited that you're
Excellent.
here. We got some great questions.
There's no one that triggers more questions than Einstein and relativity, and we got the man for it.
Well, I would say Einstein, relativity, and Tyson.
And what?
And Tyson.
No.
Okay, right on.
Okay. All right, so Jim, you published a book in 2019 called Proving Einstein Right. And let me get the full title, The Daring Expeditions That Changed How We Look at the Universe.
Sure.
And do you have a co-author? Who was that?
I do have a wonderful co-author. Her name is Kathy Pelletier. She lives in Allagash, Maine, which is just right across walking to Canada. And this book is not what people expected. Usually, Neil, your first book, as I recall, was partly autobiographical, right?
Well, that was one of my first, my fourth book. Yeah.
Okay, fourth.
Yeah.
So what I wanted to do with this was to do something I had never seen done before with physicists. Usually people talk about the wonder and the majesty of looking at nature and the struggle and what have you. But what I wanted to do, and I had wanted to do this for a decade, is to write a book about the interior lives of the people who do the science. And so this book is actually dedicated to 8 astronomers and Albert Einstein. And we tell the scientific story, but what we really want to do is get inside of their heads and tell the story of what they were feeling as they went through this almost decade-long struggle. So the book surprises people.
Okay, so the book is published in 2019, and if I remember my history, that's basically the centennial of this big experiment that showed that Einstein was right.
That's right. And
but let me back up a little bit. So most people, physicists know Einstein for many things, of course, but for special relativity and general relativity. I think often when people think of Einstein, they think of the effects of sort of ordinary relativity, like time dilation and this sort of thing. So that would all happen in 1905.
That's correct.
So why, if that's all happened and it worked and it was, it was smoke and effective at explaining our understanding of the universe, why didn't everybody say, yeah, Einstein's the man? Why did it have to wait another 10 years for them to prove some other thing that he did?
So let me talk about Einstein in 1905. And thank you for giving me this opening. As you know, Neil, in 2005, there was the so-called Einstein Year of Physics, and there were celebrations all over the world. I gave 37 talks on 6 continents on Einstein in that year.
So, I thought there were only 5 continents. No, how many? No, I guess there are 7. I get my numbers confused.
I thank you.
You left out Antarctica. Yeah, okay.
Because that's the one I've never been to.
But the penguins will welcome you with open arms.
And happy feet, yes.
Yeah, but the point was, yes, you're right, Neil. In 1905, he came up with some amazing things about space and time and how they bend and warp and what have you. But do you know that in 1907, he was still in the patent office? People think that as soon as he came up with his wonderful theories, the world beat a path to his door saying, Hosea, Hosea, whatever. But no, that's not what happened.
It's Hosanna. No, wait, Hosea.
Whoops.
Yeah, Hosea is the prophet, but Hosanna is the praise. But we knew what you meant.
Well, this is what happens when you go off script, guys. Sorry. But anyhow.
I'm sorry.
No, but you're right. But the point was that he did this great piece of work, but it took 2 years for the physics community to recognize what he had done.
Wow.
While he was in that patent office still trying to figure out how to get a job as a physics professor, he looked out the window one day and he saw some workmen on a roof. And he had this sort of story coming to him that if one of the guys fell, he wouldn't feel his weight. And so that started Einstein thinking about gravity.
He's thinking of the death of someone working on a roof next door. I did not know this.
Well, not the actual death, but the process that would lead to it.
Yeah. That's right. Just his fall to imminent death.
Yeah, that's right. The imminent fall.
Okay, I did know Einstein had this morbid side of him.
Yes. And so,
however, let me just say, I totally get it, because I think about the death of the guy that blows that leaf blower outside my bedroom window every Saturday morning. So,
and so Einstein started thinking about gravity, so this is like in fact, he calls this the happiest thought of his life.
So Jim, this is like Newton's apple moment.
Yes.
Where he sees the apple falling, and then he sees the moon, and then there's a eureka moment in there.
And that's what happened with Einstein in 1907. So the thing that's curious about Einstein is, although people think about him as this mathematical genius, every time he did something, he actually had to learn more mathematics. So he didn't actually have the mathematics to realize what his intuition was. And he didn't get it right until 1915 or 16.
Jim, that happens to me all the time. I have thoughts. I have to invent new math to, that's just a thing.
Yeah.
Well, some of us actually do that, Neil. That's another whole story, and I'll tell you about that one later. But anyhow, so he had this idea that took him almost a decade to get it down to the mathematics. And when he finished it, it was the theory of general relativity. It's the piece of thing that tells us that there was a Big Bang. It's the piece of mathematics that lets us know we live in a universe that is 13.8 billion years old. And so that came from that 1917 epiphany.
Wow.
Wait, no, I mean 1907.
1907.
Right.
Now, remember, it's all math. It's all math.
Mm-hmm.
So if it's all math, how do you know he got it right?
Right. Just because the math works doesn't mean it has to correspond to any objective reality.
Exactly. And so when he finally gets his discussion together, in fact, even before he gets the right answer, he starts talking about it. He starts giving talks about it. And so very early on, astronomers he realizes first, that astronomers would be critical to try to prove that his math is actually, as you said, Neil, something that happens in the real world. And he begins it by talking to this German astronomer named Erwin Findley Freundlich.
I'd never heard of the guy.
No one's ever heard of the guy. But
if I'd ever met someone named Irving Findley Freundlich,
yes,
I'd remember that. I'm pretty sure.
Well, I have sent for your program. I've sent some photographs of all the people that we're going to talk about. That's the first guy that Einstein starts talking to seriously. As I have a way to prove my math. And he first starts saying, if you look at starlights, could you show that starlight bends when it passes near Jupiter? And the astronomer says, no, that doesn't quite work. Then he starts asking questions about, well, suppose we were looking at the night sky in the morning or early morning or late afternoon. Could we see bending starlight around perhaps Venus or something? And the guy says, the astronomers come back, no, that won't work. And so finally, by this set of discussions with Freundlich, he hits upon the idea that if you could watch starlight during an eclipse,
right,
you might be able to see the light being bent by the sun.
Because you can't otherwise see a star in broad daylight.
Exactly. So, it's a very special circumstance. And so that starts the race.
Okay, so this bending of starlight would have been the first experimental verification of his general theory of relativity.
Yes.
And okay, and so now, so what year did that happen? Was that conversation?
These conversations around 1912 or so that he starts telling other people about these ideas.
Okay, and that's how you get the creativity of other people to help you figure out how to make it work.
Bingo, and that's what our book is about. It's about the other people. It's not really about Einstein.
Okay, so what's all this we hear about his wife possibly being a big engine to his creativity?
A lot of people have. Well, there's this one book, Einstein's Wife, I think is the title. There are a lot of people who have posited that as having been important. But from my reading of the history, she was certainly his partner as he was working through in Bern as a poor patent examiner trying to do physics. She was certainly a partner.
Bern, the city in Germany. Bern.
The city in Switzerland.
Oh, Switzerland, excuse me. Right. Mm-hmm.
She certainly was his partner there. But in the actual settling of the special theory of relativity, and I've read over a dozen books trying to get this straight in my own head. The preponderance of evidence is that he worked it out with a friend of his on a tram ride, thinking about the clock tower in the city of Bern. Okay. So, I mean, it's a fantastic story. So,
what you're saying here, Jim, is had Einstein been a loner and not traveled anywhere, he wouldn't have come up with any of his ideas.
That's
how much life exposure is the right amount to fully realize your creativity that can be expressed?
I tell people all the time that being a scientist means that you swim in a sea of information, and that information comes from your colleagues. And so you cannot be, I know the archetype, stereotyped view is that as a scientist, you go off in the corner and you sort of think big thoughts. But that's not what actually happens. I've lived this life for over 30 years, and you are constantly in conversation with your colleagues, and you use them to hone and to refine your thoughts and distill your thoughts and curate your thoughts.
So Jim, the active word there is that you are swimming in these influences, not drowning in the influences.
I was going to say, yeah.
Yeah. So that's why with Kathy Pelletier, we wanted to talk about these people that basically were using what Einstein inspired them to do, but to swim towards this discovery of whether his math was an accurate description of nature.
Wow.
Do you think Einstein had any doubts about whether it was all true?
From my reading, no. He sort of says things like, if the theory of general relativity had failed to receive experimental and observation support, that he would have felt sorry for the good Lord.
Because that was a really brilliant idea.
Right. Which is kind of way of saying, like, I'm smarter than God. So
yeah, it definitely says that.
Yeah.
No, it doesn't. It really doesn't.
No, Jim, you're lying. Jim.
No, I'm not lying. If you read a lot about Einstein, you find out he's a very, very complicated character. And if Chuck, since you brought up the issue of God,
okay,
and you did bring it up.
I did, yeah. I mean, to me, when somebody says that statement, it kind of sounds like, I'm smarter than God.
No. But you see, Einstein's, although you can interpret that statement that way, that's not really what Einstein felt. Because, in fact, he talks also about the illimitable spirit. That is a spirit without limits. So it's clear that if you could use a phrase like that, you're not putting yourself above such an entity.
Okay.
All right. That's a very good point.
He didn't use that phrase in that sentence, though, but okay.
Not in that sentence.
In that moment, he felt badass, is all I'm saying.
Yeah. It's not, but yeah.
Because it is, Jim, before we go into the second segment and solicit our cosmic queries, just give me a minute or two. I know it should be hours or two, but give me a minute or two on the idea that math is just something we invented as humans.
Yeah.
And it works. What's up with that? There's
Neil,
no reason that it should work at all.
Neil, this is the only piece of magic that I've ever experienced and seen in reality.
I love that. It's magic.
It's a piece of magic, but it happens to be a part of our reality. I don't know of any other form of magic for which I can say this.
And this is human-created magic. We create something, and it magically describes reality and enables you to predict and understand and extend.
It acts like a third eye for those of us who are scientists. It lets us see things that are not seeable otherwise. I made a presentation at the New York Academy of Sciences about 2 years ago, and it's precisely on this point of the magic ability of mathematics. It's an hour-long interview, so I'm not going to bore you with it, but I would...
Wait, is it on YouTube or something, or is it...
Yeah, it's available on YouTube, absolutely.
Well, forgive me, I'll go find it. I'm going to find it. Okay, the New York Academy of Sciences, a long-venerated institution.
Absolutely, and I was there with Margaret Wertheim, and we discussed this magical thing, this thing about mathematics. And at the end of the day, one of the things I said about it is that mathematics, as people like me use it, it's the only human language that we know accurately allows us to describe nature. However, any other conscious being that could produce mathematics will have access to this knowledge.
So hence the idea that if we meet up with aliens, we might start with this symbolic representation of what is and is not.
Sure.
And math could be the only way we can prevent ourselves from getting our brains sucked out by the evil ways.
Many of us think that that's right.
So when we come back, more of this edition of Star Talk, where we're talking about proving Einstein right. And we're going to go straight to our Cosmic Queries version of that when we return.
Exploring the secrets of the cosmos is a fascinating pursuit, but have you discovered the vast and incredible potential of your own mind? Introducing Advanced Nootropic Formula from V-Thrive, the Vitamin Shop brand. Available at vitaminshop.com or your local Vitamin Shop store. This stimulant-free formula supports cognitive function, neuron development and repair, and brain-derived nootropic factor to promote the survival of existing neurons and encourage growth of new synapses. Non-GMO Advanced Nootropic Formula features clinically studied ingredients like Synapsa for peak cognitive performance, Cognizant for mental energy, focus, and attention, and clinically proven in extras so you can stay extra sharp. In fact, you may experience an improvement in alertness for up to 5 hours. As always, all V-Thrive, the Vitamin Shop brand products, are simply clean with no magnesium, stearate, stearic acid, or titanium dioxide. Advanced Nootropic Formula comes with a quality promise you can trust with ingredient purity and potency verified by independent third-party labs. The best part? It's on sale. Save 15% on purchases of $40 or more when you use code STARTALK at vitaminshop.com today. Again, that's 15% off purchases of $40 or more with code STARTALK on vitaminshop, SHOPPE.com to expand your mental universe today. Are you always taking care of your family? Do you often take care of others and not yourself? Well, now's the time to take care of yourself because you deserve it. Teladoc gives you access to licensed therapists to help you get back to feeling your best, to feeling like yourself again. Sometimes we don't know how much we need to talk to somebody. Take it from me personally. During the entire pandemic, I have had virtual sessions, and it has been such an incredible help. Now, with Teladoc, you can speak to a licensed therapist by phone or video. Therapy appointments are available 7 days a week from 7 a.m. to 9 p.m. local time. Hey, maybe you're feeling overwhelmed. Maybe you feel stressed or anxious or depressed or lonely, or you might be struggling with a family issue. Teladoc can help. No need to wait months to get a therapist. Teladoc is committed to facilitating great therapeutic matches so they make it easy to change counselors if needed for free. Teladoc therapy is available through most insurance or employers, and individual plans are also available. Download the app or visit teladoc.com/StarTalk today to get started. TELADOC.com/StarTalk.
We're back. Star Talk. Proving Einstein right. Ooh. Chuck, thanks for being there, as always.
Always a pleasure. Always a pleasure.
And we got Sylvester Jim Gates, a longtime friend and colleague, who's an Einstein expert, a theoretical physics expert. He's all the kind of expert you need for this.
Absolutely.
for this incarnation of Star Talk. And we're going to devote this segment to cosmic queries. Jim, your presence on our show was announced to our fan base, and they got completely excited by this prospect.
Oh my goodness.
So I have 5%, no, I have 3% overlap with Jim's expertise in this subject. So if I can find a 3% way to add, I will. But basically, this is all going to Jim.
Okay.
So, Chuck.
Excellent. And
Do it.
Not that it needs to be said, but I have 0% overlap with Jim, which is why I'm reading the questions. So here we go.
All right.
Let's start. You know what? Before we start, let me just quickly, can you, Professor, give us a quick breakdown between the special and the general when it comes to relativity? I think that might be a nice framework for anybody who didn't ask a question to be a part.
Good.
Thank you, Chuck. So let me start with special because it's simpler. You know, if you were standing by a road and there was a car that was speeding towards you with its horn blaring, what would you actually hear? It would go something like, ah.
Right. Yeah.
Right, because you hear that dip in the tone.
That sounded like you were dying.
I was going to say, yeah.
No, I could do better than that. Here you go. Ready?
Okay, so we'll go with.
Let's work with that. Nothing's dying.
We'll work with the cat sound.
By the way, in his spare time, Neil does sound effects for Warner Brothers.
I can see. And so the point is that effect is because sound changes its frequency if it's moving towards you. That's when it's high pitched. But if it's moving away from you, this pitch goes down. No. Exactly. So the point is light actually does the same thing. When a light source is coming towards you, it appears to be bluer than it actually is. When it's moving away from you, it is appearing to be redder. And that is one of the primary effects of special relativity. It's about the relative motion of you and the source of the light. In my car analogy, it's this motion of the car either towards or with you. So that's what special relativity is all about, is if I'm moving and you're not, how do I perceive things? How do you perceive things? That's the simplest. That's my 5-minute class on special relativity.
Cool.
We good?
And then
now general relativity.
Can you juxtapose that against the general and the distribution of mass and all that stuff?
So the general theory of relativity is something very, very, very different. And what the general theory of relativity is about is, what is gravity? You see, in the special relativity, Einstein wasn't thinking about gravity. He was just thinking about how things would look if I'm moving. But in the general theory of relativity, the question is, what actually is gravity? It's a very deep question that even Sir Isaac Newton didn't get the answer to. And the answer that Einstein teaches us through his mathematical wizardry is that gravity is the space which we move through and time which we experience durations in are combined to this thing he called space-time, and gravity is the bending of this thing. So that's my short course on general relativity.
Cool.
Well, there you go.
All right. That was great. Okay, let's go to Izzy Rohr, who says...
Wait, is this Patreon? Do we do Patreon people first?
Yes, sir. Thank you.
Yeah.
Yes, we always start with a Patreon question because Patreon people give us money. So, and for that, we are grateful. And we show our gratitude by giving you special preference.
Wait. So, but Chuck.
Yeah, we're just like Congress. We're just like your congressman.
But Chuck, this just in. Apparently, all your questions are Patreon questions. I've just learned.
Oh, excellent.
Okay.
This just in.
Every single one of them. So guess what? All of you.
Let's go.
So thank you to all of you. Izzy Rohr, Neil, Chuck, Jim. This is your friend Violetta, the astrophysics-loving kid here in Birmingham, Alabama. My mom. Oh, you know her? Okay, cool.
We've been in contact.
Excellent. My mom and I have had many discussions about this. Scientists like to describe Einstein's general relativity as being incompatible with quantum mechanics. They say things like they mathematically don't work out or don't work together. So our question is, why the heck is that?
So it's,
Jim. Yeah, what's up with that?
Okay. So let me give me a second here because I got to phrase this without the mathematics. So the idea
that is so funny, by the way. Okay, let me just say that may have been the most physics thing I've heard in a very long time. I've got to figure out a way to say this without the mathematics.
Well, you see, I don't know if you folks...
It's like, I'm sorry, me no speak English, me speak mathematics.
Me speak.
Well,
speak English.
Chuck, you may not know this, but Neil can tell you this. Often at the end of my email messages, I ask forgiveness for spelling and punctuation errors because my first language is mathematics.
Ooh!
English is my second language. And so I'm at a disability when people ask me to talk.
Listen, I've never heard a person admit a fault that makes you better than most people.
I don't know about that. But it causes me difficulties, Chuck, on many, many occasions.
Okay.
Back to quantum. Okay, so what essentially happens is if you believe the universe is quantum mechanical, then it forces you to forget about things like electrons. Because electrons we think about as little tiny balls. That's the classical picture that you're taught. And in fact, quantum mechanics says, no, that's not the way it works for electrons. You have to think of these things that are more like waves, except when they act like particles. So that's the first thing it gives you this really weird thing that you have to give up an idea, except sometimes, right? It's really
right.
Okay, so now so there's a piece of mathematics around this called Schrodinger's equation. So I got to bring that in. And it tells you how to calculate.
If you're going to bring up Schrodinger, you can't leave out his cat.
Exactly.
So just keep going.
Okay.
Or that litter box, which hasn't been changed in God knows how long.
Well,
Schrodinger's litter box.
That's what I'm about. Schrodinger's litter box.
We can also go back to Neil's rendition of a car horn as it approaches you. But anyhow, so you have a piece of mathematics around giving up the idea of particles. And when you now give that piece of mathematics up and try to do gravity, you find out you just get into a total mess that you cannot calculate answers anymore that take into account the quantum behavior. And that's the mess.
So that's the disconnect there, is that Schrodinger's equation, once you remove anything, none of the gravity stuff works.
Because the way that Einstein and Newton and all those folks thought about gravity has the idea of particles embedded in it. That's the problem.
All right. So who's at the end of the day? Who's got to give? Is gravity going to bend to quantum physics, or is
I see what you did there. I saw what you did there, Neil.
With the gravity bends, yeah.
Yes.
Yeah. Mm-hmm, mm-hmm.
So Neil, this is actually a very deep question.
Or is there a third idea bigger than both of those that then encloses them under one umbrella?
Oh,
there are variants of all of everything that you've just said. Well, first of all, who's going to bend? There are people who will tell you that gravity is going to be one that loses this discussion.
If I had to bet, I'd lean that way too. Yeah.
Yeah, and there are a lot of people who believe that somehow gravity is going to have to give way in some manner. There are other people who have this third idea approach that you were talking about, Neil, and one of those, and sort of emblematic of that is a discussion that's underway about information and black holes. I know Neil is probably aware of this, but there's this whole discussion about whether information is conserved, like we say energy is conserved, is information conserved? And if you have a universe with black holes, doesn't that mean that some of the energy some of the information disappears? And then you violate a conservation law. So there's a whole big discussion in theoretical physics that's been underway for over a decade about black holes and information
All right. So when you talk about information, are you referring to, because we just talked about this last week, give me 1 second, please. that when Neil was talking about virtual particles and the evaporation of a black hole, and if I'm not mistaken, then this particle actually materializes on the outside of the black hole, and then that is what escapes. And so then if that were to happen, are you saying that that somehow messes up this whole idea of the conservation of information?
Yes. And Chuck, you were really paying attention in that episode.
It does seem like it. That's
Man,
exactly right.
Chuck.
Neil, why do you think I do this job, man? I'm getting a free education.
Damn, Chuck.
Yeah. Okay. So that's what. Okay. But
the point is that it's in a state of flux. We don't know what the final solution is going to be. But many people like me actually think that string theory will have something to do with the resolution.
Mm-hmm.
Okay.
So the string people think this. Yeah.
Well, it's not just string people, I think. I don't consider myself a string person, for example. I am someone who's spent their life working on supersymmetry, and strings happen to intersect that.
Okay. Well, I consider myself a string cheese person. So
string cheese, yes.
That's about as close as I'm getting to it. All right, cool.
All right, go next one.
Here we go. This is Paul Vogel, who says, recently, between the detection of gravitational waves and a photo of an event horizon of a black hole, some significant predictions made by Einstein's general relativity have been verified. What's the next big prediction made by general relativity that scientists are testing? Thank you.
So that's a great question, and it's a great question, and the answer is the following. In 1905, Einstein wrote 4 papers. Among those 4 papers is one that points out that energy has to be quantized. Now, we know that Einstein doesn't like quantum theory, but in fact, he's one of the fathers of quantum theory because of this 1905 paper on the photoelectric effect. That when you
Just to be clear, he didn't like it because he didn't think the universe should be probabilistic, right?
That's exactly right. He wanted determinism, as it's called, whereas as quantum mechanics says, no, you can't have determinism. You have to go with probabilities. So the answer to your question, Chuck, is now that we have seen waves of gravity, we want to see the quantization of the energy carried by those waves. Because when we do that, we will have the Star Trek graviton in our universe.
So the same way we know light has a particle, are you saying that gravity has a particle? Or wait a minute, it would have to be that we find this gravity particle?
That's correct. That's the next big prediction that I want to find from the kind of experiments watching gravity waves. You want to be able to see the quantization of the energy that the gravity waves hold. That tells you that gravitons, just like you hear in Star Trek, you always talk about graviton waves. At that point, it is no longer science fiction. It's a piece of science.
Wait, and Chuck, just to follow your line, so a photon is a particle of light, but you can also speak of light as waves.
Right.
Right. So that is a proper analogy. We've measured gravitational waves. Now we want to measure the gravitational particle.
Oh my God!
You have the photon, then you have the graviton. So I don't know any experiments out there to measure a graviton. Is there something in the works?
No, nothing to my knowledge, Neil. I don't know anyone this is going to have to be an exquisite experiment. And we're just at the stage of just being able to see the gravity waves. So, is it 50 years? Is it 100 years? I don't know. But as our technology improves, someone is eventually going to figure out how to do that detection. And then we can stop saying that Captain Kirk is the only guy who gets to talk about gravitons.
So just a quick question. If we have gravitons, then gravity being the curvature of space and time has no meaning in the presence of a graviton.
You're following along here. For a lot of people, the detection of a graviton will likely necessitate a real rethinking of what gravity is. Some of us already are there. I don't actually think about gravity in terms of geometry. It's field theory. That's the tool for people like us.
All right. So what you're saying is Einstein's curved space happens to be a convenience under certain situations that get you the right answer.
Yes.
And you're good with that, but it's not the total story.
Nope.
Okay.
Wow.
There you go.
Okay. Yeah, that is...
So just let the record show, Chuck, that Jim Gates just said Einstein had his head up his ass. Okay? He just said that, just to make it clear.
That's funny. Okay. James is like, I'm not saying that.
I'm not saying
I didn't say
James is
that.
like, I'm not saying that. It was like, send your letters to Neil. The professor's like, send your letters to Neil because I did not say that. Okay. All right.
Actually, we got to take a break. And
Okay.
when we come back, we'll go to our third and final segment of Cosmic Queries, proving Einstein right on Star Talk.
So you're ready to earn your degree, but you need a university that works with your schedule. Well, WGU and their programs are built to be flexible. WGU offers a quality degree program that's affordable and even makes it possible to graduate faster. Plus, you can earn a respected bachelor's or master's degree for under $8,700 per year, fees included. That's right, you heard me. That is the correct, $8,700 per year. Let your experience and dedication help you earn your degree faster. See what WGU's competency-based programs can offer you. With no set login times and 24/7 access to most coursework, you can really earn a respected bachelor's or master's degree on your own schedule. The low tuition rate covers as many courses as you can complete each term. That means the faster you learn, the more you'll save. Get your $65 application fee waived at wgu.edu/StarTalk. That's wgu.edu/StarTalk for your $65 application fee. Poof, gone, waived. Hey, we'd like to give a Patreon shout out to the following Patreon patrons: Beverly Bellows and Christopher Mank. Guys, thank you so much. What would we do without you as we make our way across the cosmos and create this show for everyone to enjoy? And if you listening would like your very own Patreon shout out, please go to patreon.com/StarTalkRadio and support us.
We're back. Star Talk, proving Einstein right. And Chuck is helping me, because you're a big fan of special and general relativity, aren't you, Chuck?
Oh, without a doubt. Are you kidding me? Come on, man.
Yeah, of course. But of course.
Some people like reality TV. I like relativity. Okay, that didn't work.
Did not work. But anyhow, but you're on social media. What's your best place people can find you on social media?
At Chuck Nice Comic. Thank you, sir. Appreciate
Chuck
that.
Nice Comic. And you even have I stumbled on this. You never told me this. I stumbled on you have a TED Talk on technology and the future.
I do. Technology and the unintended consequences of human interactions. So,
or the absence of human interaction via technology.
Exactly.
Yes, I stumbled on that. I'm angry with you for not telling me in advance about that, because I have to find that on my own. We've got Jim Gates, an expert in theoretical physics. Jim, do you have a social media platform?
I do. It's Dr. Jim Gates. You can see there's a Twitter version and a Facebook version, but it's
Doctor. It's just DR, I presume.
Just DR.
Yeah. All right. We'll find you there. And you've got this book, Proving Einstein Right.
Yes.
And co-authored with Kathy Pelletier.
Yes.
Yeah. So we're continuing our cosmic queries. And just before we begin, and Chuck, before you read one in, Jim, you've got a background there that looks kind of spacey, actually, but then not quite.
Yes.
So could you give us a minute on that?
Sure. So I'm in the odd position, Neil, where it looks like both of my twin children are going to become physicists. So this is, this is not something I set out to do, but
right. Yeah. keep telling yourself that. Okay.
So my daughter works on black holes. And so she's actually started publishing, and I actually had a chance to watch her give a talk this week. So, big props to my daughter. Her name is Delilah. But I also got to give big props to my son. The background that you're looking at, these green little splotches are artificial neurons that he's been growing in the laboratory, because it looks like he's going to be a biophysicist.
Wow.
As a host.
Okay, Chuck, he's creating the next generation superhero or superhero villain.
Yeah, without a doubt.
Black holes and growing neurons. So that's it.
So
that's it right there.
The daughter will harness the power of the black hole, and the son will imbue some some being with that power to rule the world.
Have you ever worried about dark side?
The dark side. There it is.
Right.
There it is.
So who knows?
Jim is breeding the dark side. Is it an actual photo or it looks like artwork?
It looks like artwork. This is actual photo of some of the first successful cell lines that he's been growing. Where you can see the evidence that they're developing a ganglia like real brain cells.
Sweet,
okay.
man.
Okay.
Wow, that's amazing.
We'll watch that space.
That's so important. Okay, cool.
All right, let's get to the next question. Chuck.
Yeah, big brain stuff going on in that family. All right, here we go. Let's go to Lisa Hansen. And she says, hello to you all from the Bay Area. String theories are so involved and fascinating. I love trying to wrap my brain around them. I'm wondering what, if any, other scientific disciplines are involved in the research for evidence and proof of these theories, what those clues might be.
Well,
clues in this real universe, Jim, and not some imagined one.
I knew he was going to say.
It's very interesting that question came up because just last summer, I did something for the first time in my life. Because I tell people I exist at the boundary of mathematics and physics, so I'm a fallen mathematician in some sense. But last summer, I published a paper along with my colleague, Stefan Alexander, here at Brown University, Evan McDonough, who was one of our postdocs, and my postdoc, Konstantinos Koutrelaitis, as well as our graduate student, Leah Jinks. And in this paper, we set out a premise that strings might be able to create structures that could potentially be observed in the cosmic microwave background. We call these structures Susie reals. They're like these funny patterns. I hope people are familiar with the CMB. It's this microwave radiation that you can detect by looking out at the universe. And what we showed in our paper is if you take the ideas of string theory seriously, they have a way of writing a kind of signature in the structure. So what kind of science do you need? You need to be an astrophysicist, someone who can actually look in microwaves at how the universe gives us a perspective.
Once again, it comes down to the astrophysicist.
There you go.
Of course, absolutely.
Just saying.
Look, Einstein.
But now, wait.
Einstein needed astronomers.
Right?
String theory may well need astrophysicists.
So that begs the question. In that collaboration, who is Batman and who is Robin?
Just a quick thing. If I remember, Stefan Alexander, he's the jazz musician, isn't that correct?
That's exactly right. Stefan is a professional level jazz musician, although he is a physicist on faculty here at Brown University.
Yeah, I should have said that differently. He's also a jazz musician. So he wrote that book, The Jazz of Physics, or The Physics of Jazz, or something.
The Jazz of Physics is his work.
Okay.
Right. Cool, man. All right. Great stuff. That's great stuff. Let's move on to Josh B., who says, who has more impressive mustache, Albert Einstein or Neil deGrasse Tyson?
Do you know, I got to say, anytime I got to show up in a movie or in a documentary and they put you in hair and makeup, and so they do the makeup, fine. And then they get to the hair and they say, can we trim your eyebrows a little? And can we get some of the loose hairs out of your mustache? And I'm saying, wait, this is my Einstein look. You want to be all trimmed and manscaped?
No,
this is not...
You need a wiry, unkempt, just wild mustache.
Yeah, so what's with that look, Jim, that Einstein sported?
So I'm not sure what the question is.
You know what? With that as the answer, we should just move on. That was hilarious. Let's just go to Sam O'Neill. Who says...
Wait. Just about 8 years ago, I just want you to know I was nominated for the Mustache Hall of Fame.
Okay.
Just so you know.
Okay.
Just so you know.
Right on.
Okay.
Well, I'm going to return that. I was once inducted into the Luxuriant Hair Association.
Very
That's
nice.
a thing?
It was at the time.
Okay.
Right. Mm-hmm.
Okay. All right.
Okay, here we go. This is from Sam O'Neill. He says, hey, Dr. Tyson. Hey, Dr. Gates. What's up, Chuck? My question is, what do you theorize that the strings in superstring theory are made of. Love you guys. I would give you money, and I do. Samantha from Earth.
Oh, from Earth. Excellent. I love that.
Well,
I love that.
my question is PayPal.
No, we're it's Patreon on this side of that fence.
Oh, okay.
But go
Well,
on.
someone's got to explain that to me.
There you go.
That's all you, Jim. So go for it.
Yeah. So the thing about string theory, which perhaps isn't completely understood, is that we don't think strings are made of anything. They are the fundamental thing if it's a correct picture of the universe.
They are the thing everything else is made of.
That's right.
So therefore, you can't say what it's made of because
Right.
it is the thing that everything's made of.
That's all we know.
Wow.
That feels like a cop-out, though.
I was about to say, that's a little circular.
Yeah, but
That's slightly circular.
Just a little bit.
No, Chuck, you're right. But you see, one of the weird things about mathematics is that you have to take some things on faith. There's actually a mathematical theorem that says this. It's called one of Gödel's theorems. And so this is one of the really weird things about math that people do not appreciate.
Well, no, Jim, be fair. It's not that you have to take it on faith. It's that you have to assert that it's true. And if you assert that it's true, then everything else works. Right? It's an assertion. It's not, gee, I hope it's... No, you just declare that it's true and then take everything from there. But you can't prove the thing that you assert that's true. That's not faith.
And therefore, it's an element of faith, Neil.
I use faith in a different...
I know you do. We have to have another discussion about
the whole faith. We'll get you.
Yes,
I said we'll get you back 7 other ways on this. On
Without a doubt.
I'd love to talk to you.
Forget Einstein. We got other business to resolve here.
If only George Michael were here to settle this debate. Okay. Sorry, pop culture reference. Shouldn't have brought it in. Here we go.
From 1980.
I know.
Damn, Chuck.
I can't help
How
it.
old are you? Damn.
He looks young, doesn't he, Neil?
He does. He uses that oil of old age.
Yeah.
You know?
Did you say oil of old age?
That's exactly what he said.
Okay, I never heard that before. I like that.
I heard that from an old friend of mine said that.
Oil of old age. I like it. All right, here we go. This is Woody. He says, after seeing Neil's enthusiastic response, what are Jim's thoughts on a cosmic gravitational background? And you just talked about the cosmic microwave background and string being able to be visible in that. What about a cosmic gravitational background? Do you have any thoughts?
This would be the paw print of the birth of the universe expressed in gravitational waves.
Right.
It would be, and I've never actually heard a scientific discussion of this, but that idea, it really seems well grounded that one could imagine. No, that if one could, look, the cosmic microwave background is an electromagnetic background. It's microwaves, right? Just like the microwaves you cook.
It's light. It's light.
Right. It's a form of light.
Right.
But a gravitational background, a gravitational signature from the Big Bang, I don't see any reason why that's not possible. I've not heard of any scientific discussions of the concept, however.
Okay, so part of why the cosmic microwave background is so useful to us, not only that it exists, but we have a very detailed map of its structure. And right now, when we're detecting gravitational waves, something happened, we think, over in that direction of the sky. You know, we have nowhere near the mapping precision to possibly do anything interesting yet. And I don't know when it would come.
Oh, I would give us about 20 to 30 years because in order to do what you're saying, Neil, first of all, we have to get a sufficient number of gravity wave detectors. Right now, there are about 4 in the world that are one. There's one, for example, in Europe. There's one in Australia, and there are 2 in the U.S. So that's the minimum number you need to do the mapping. And they're not all sort of fully functional. So we got some time.
Right, and then you want to get gravitational waves of different wavelengths.
That's
right, and so it's not just this one that came through. Get the whole spectrum, if I can borrow that word from light, and then you have this 2 dimensions of information
exactly
to interpret.
Exactly.
So we're not there yet. But if we were there, it would tell us a whole lot about the very first moments of the universe.
Exactly, and that's where science is pushing toward.
Cool.
Yeah,
that is super, super cool. All right, Roman Prekop says this. Is it possible that some of the stars observed in the night sky are duplicated or multiply duplicated due to light bending in gravitational fields of a massive object like some super black hole?
I should let Neil answer.
Yeah, I could take
Thank
that.
you. Go ahead, Neil.
Yeah, I could take that one. So the answer is yes. Next question. No, so what happens is that the way this unfolds, by the way, Einstein first predicted that you could make a ring, we call it Einstein ring, where the light would bend symmetrically in all directions around a single object and create a ring of light from that single object from behind. It turns out that's not realistic because that requires exact lineup.
Right.
So that there's a perfect geometry of all sight lines that go around it. Most things don't line up exactly. But when we do find them sort of line up, even if not exactly, you find distortions that resemble rings. They're arcs.
Right.
They don't make a full ring, but they make arcs. Now, if you have one object behind, that object will make a minimum of 3 images. One that comes straight through, and then 2 that come around the side. Mm-hmm. And up from there, it can make 3, 5, or 7 images. So yes, in fact, it's just something cool. Here's something cool. You ready? Okay. So we found objects, quasars, whose light bent around galaxy clusters that were sort of midway, right? From Einstein's gravity. But the path lengths were not the same. Okay, so the path on one side is a little longer than the path on the other. Now, you know how we know? Because quasars vary. They have explosions. The light varies. So we see it, and it varies up here, and then a scheduled time later, it varies over in exactly the same way. So you get to see the same event twice.
That's because of the change in intensity of light due to the explosion? Is that what's happening?
Well, no, there are things, the quasars can eat things episodically.
Okay.
There are a lot of weird things, episodic things that can happen in quasars. But the fact that you have 2 different path lengths is extraordinary testing of the shape of the curvature of space and how much gravity is in the cluster and how far away the quasar is. So it's an amazing thing.
So it's funny to me that you've come back to this because this is what my daughter works on. We talked about the cells behind me, but when you have rings of matter around rotating black holes.
Chuck, he's just giving equal time here.
I know, exactly.
Because he didn't want to pick his children.
He's a good dad.
He's a good dad. Good dad. Go on, good dad.
But when you have rings of matter that glow around spinning black holes, you can actually see the backside of the ring because the gravity bends the light from the growing light. That's what my daughter works on.
Yeah, that's very cool, man.
I want one last quick one, and we got to call it. We're over time.
We'll be done with it. Okay.
Yeah, Chuck, go ahead.
This is from Glenn. He says, Dr. Gates, do you think that white holes exist? Was Einstein observing what was Einstein observing that gave him the impression that they did? All right. Now, I'm just going to answer this for you. No, there are no white holes. Einstein was a racist like everybody else back at that time and just couldn't let it be just
started
black.
Off, Chuck.
Couldn't just let it be a black hole, could you? Okay? Yeah. So, no, go ahead.
Chuck got that off his chest.
You know what? Here's what I love about the professor. He's sitting there like, I have nothing to do with this. Whatever Chuck is saying right now, that's his crazy business.
I only just met Chuck.
Exactly. He's like, I don't know this man. All right, go ahead. Sorry.
Okay, so
and make it quick, Jim.
Yeah. So what's really interesting is black holes aren't black. It turns out that because of Stephen Hawking, we know that they actually have this very slight radiation called Hawking radiation. So they're not exactly black. That went out a long time ago. So, got to keep up with the news in physics.
Okay, but the white hole concept.
The white hole concept, people who... Look, I don't know of any solid scientific arguments about the existence of such things. I have not encountered.
Okay. And plus, we don't see anything in the universe that would resemble what a white hole would be predicted to be, which would be the mathematical opposite of a black hole, right? Yeah. So everything is spewing out, and that should look like something in the signature of light.
It should be something spectacular. We don't see it.
Yeah. But we really got to cut it there. Okay. Jim, we got to get you back for 9 other subjects.
That's okay, Neil.
Okay, we got you on the Rolodex.
I got game.
All right, and we'll get a picture from your other child's twin child behind you on the next program.
Okay, so black holes, man, black holes.
Chuck, always good to have you.
Always a pleasure.
All right, this has been Star Talk. I'm Neil deGrasse Tyson, your personal astrophysicist. As always, keep looking up.
With Masterclass, you can learn from the world's best minds anytime, anywhere, at your own pace. Learn how to ace your opponent from Serena. Improve your writing skills with Neil Gaiman. Learn how to negotiate with Chris Voss. All right. Those were the courses I chose, but you'll have over 90 classes to make your own choice, and they're all taught by world-class instructors. Now, of course, the master instructor, Dr. Neil Degrasse Tyson, has a masterclass of his own on scientific thinking and communication, and we all know how important that is in these times. I'm not the only one who's benefiting from my masterclass. My brother is an avid tennis player, and I sent him the gift of a subscription so he could get schooled by Serena. Did I tell him that it was a part of my subscription? Well, let's just say the answer rhymes with ho, ho, ho. From learning how to write anything from a book to a screenplay to communicating with your boss to how to make dinner worthy of a Michelin star or just the best scrambled eggs this side of a jumpy chicken, there's a master class for you. I'm in the middle of a course on sex and communication because I'm good at one of those things. Masterclass is accessible on your phone, web, or smart TV. You can get an annual membership to Masterclass and give one to someone else for free. Get unlimited access to every Masterclass for you and a friend right now. Just go to masterclass.com/StarTalkRadio. That's masterclass.com/StarTalkRadio.